This video explains the electric car versus fuel car comparison Excel document. So we'll start from the top. This here is where you indicate CPI. This is where you indicate the number of years you'd like to forecast out over. The blue are electric vehicle costs and the pink are ICE costs. So cost of the car, we'll say, is 50,000. 20 cents for off-peak, and then 30 for peak. Size of the battery, so 50 kilowatts we'll say for an Atto. Range, that you just leave that 100%. Expected range for the Atto is around 500. It's actually more, but we'll keep it conservative. Insurance, Rego. The Rego has gone down in Victoria. That's why it's 800, not 900. Servicing is obtained from this table over here. So EV servicing costs per annum, as you can see, and then fuel servicing costs there. Doesn't really take into account the increased. No, you can make that whatever you want. That's why I've actually made it $300, because an ICE after a 10-year period will definitely start losing bits and requiring one of the 2,500 moving parts to be replaced, as opposed to the electric vehicle, which has less than 30. So I've given the ICE. Oh, you know what? Make it 40,000. Current fuel. It's around, we'll call it $2. The 70 litre tank, it can do 700 kilometers, we'll call it, and that's it. So you can see here that the cost per kilometer is 20 cents, even increasing the cost per kilometer. The cost per kilometer is 10 times less for electric already, just taking those simple metrics into account. You can also see here, this here is a price comparison over a 10-year period. So over 10 years, with just these values alone, it's going to cost $70,000 as opposed to $20,000, not including the cost of the vehicle. When you include the cost of the vehicle, it's without including depreciation, which gets a little bit tricky, but we do have CPI included in it. It's actually all proportional. That's it. But as you can see, $120,000 as opposed to 71. So the only other field that's malleable here is the kilometers per day. So that's going to be different for everyone. But once again, it's a linear thing. So if it goes from 30 to 300, it's quite substantial. Yeah, because of the fuel costs, I'm guessing. Yeah. All right. Anyway, sorry. So we'll get back to the business. So we'll make it 100 kilometers a day, and then that equals 500 kilometers per week. Take into account a 5-day week and 48 weeks per year, just to be conservative. So then this ends up being the 10-year cost off peak, peak for the power. On roads as 17,000, as you can see, and then this is all basically the summing up of the costs for both the ICE and the electric car. You can see there they're actually on roads are the same. So then we move into the totals. So total cost if powered by solar, which is equal to nothing because it's free, ends up just being servicing costs. So yeah, that's it. So as we continue to move down here, we see that really shouldn't be the word savings for 10 years including car, but what I might do actually, I might make it such that you can actually modify or at least see the formulas. Otherwise it's a bit useless because you can't check it. Anyway, savings is $53,000 if you buy an electric car over an ICE car, not including the cost of the vehicle. That's it. And then savings of off peak and then peak. So as you can see, actually it's quite interesting. There's insignificant saving associated with the difference between having solar and not having solar. You know, yeah, $5,000 or $4,000 ish over a what period was it? 10 years is basically nothing. But you can see it's 4 times financially better off to have an electric vehicle over an ICE vehicle over a 10-year period. And then, yes, off peak is 2.6, and then off peak is 2.7 times better. So very little difference there, as you can see, between peak and off peak. What else? Yeah, that's it.